So good evening again, ladies and gentlemen. So this is the last of the two videos and the last element in the lesson. So I really hope that this lesson that I have created has helped to prepare you for our session for the next class, because as I said, after that class, I will not be going over this topic because it's one of the simpler topics. And I guess that is why I've taken the time to create this lesson. I had given the lesson 60 minutes. So I do hope that everything fits into the timeline. But let me stop chatting and rambling. And let's get into the algebraic approach. So this is the second of the two approaches that you can use in order to deal with questions, learning curve questions. Now, I'm not going to be using the Captain Charles, but coincidentally, you could still use the same algebraic approach in order to work that out. But I'm not going to try to confuse the public this evening. So we're going to keep the approaches separate using separate questions. So in this question, notice that you have been given the learning curve rate, which is 80% again. But notice the absence of these doubling up of figures. There's no second product, there's no third and fourth, there's no fifth, sixth, seventh, or eighth product, there are no 4 units. We are just dealing with some random numbers. And once you see your question structured like this, it means that you cannot use a tabular approach. You have to use what is called the algebraic approach. And in the YouTube video, you got your first introduction. That first YouTube video, you did get your first introduction, and you are given a formula y, which is called the cumulative average time per unit. So it's very important that you appreciate that this value y is being calculated for a single unit. Now let us look at the rest of the question. We have been told that at the end of June, 30 units of this product ABC has been used. Now notice the keyword new product. So that will tell you that learning curve will be applicable here. Now, July comes around and they want to make 5 more units because that is what the budget for July says. Now, importantly, they have given you the time for the very first unit. Now, in your formula for y, it starts out with a value called a. And if you remember, a was the time given for the first unit to be made. So for this question, a is 120 hours. We multiplied by a quantity x, which is raised to the power, let me see if I can find it, which is raised to the power of minus b. I'm trying to see if I can find it in, right, so I want superscript. And I'm going to put, I'm going to put superscript minus b. Minus b. All right, so the formula is very simple and the application of it is very simple. So in the question, we have a, which is, let me put that in quickly, 120 hours. We have b, and b, we were given the the learning rate and not the decimal. To get the decimal for B, it's the log of 0.8 divided by the log of 2. Now, that formula was given to you in the first PowerPoint, the first YouTube video. But normally in the examination, I would tell you what B is. But let me just calculate it here for you. Oh, I think it was minus 0.322. Let me just check it because I don't have my calculator. Right, so it's minus 0.3219. Let me use that. So in the question though, in the exam though, I would give you B. Okay? And remember now, B is a negative value because we're seeing reduction in rates, reduction in production times. So what we don't have in this question is X. Well, what we don't have identified, sorry, in this formula is X. Now, I'm going to draw 2 bands of color. And I'm going to see if I can use this to illustrate how we use the algebraic approach. Now let us look at question A. Question A says, calculate the time required for the 31st unit. Now, if you're going to do that, you have to first calculate the time for the 30th unit. Then you calculate the time for the 31st unit. You'll soon see what I'm doing. So when you're using algebraic approach, if you want to work out the 31st unit, or any unit for that matter, you have to find the time for the unit before that. So let us say, for example, that the time for the 31st, the 30th unit, the time for the 30th unit, come on, cooperate. The time for the 30th unit was, I don't know why this thing is cooperating. The time, this timeline here, let us say that it was 35.27 hours or 350 hours. So when you did your calculation, you found out that the time for the 30th unit was 350 hours. And when you did the calculation, you found that the time for your 31st minute was 355 hours. Once you have those two times, the time for the 31st must be this section here. The difference between those two times. So this section here that I'm going to highlight in a lighter shade, that section is the time for the 31st unit. So this is the time for the 31 units. I probably should change this. The time for 31 units, probably tired. The time for 30 units, let me change, it's supposed to be 30 units. Let me repeat now. So if this is the time it takes to make 30 units, and this is the time it takes to make 31 units, then it means that the time for the 31st unit must be the difference between this figure, the 355 hours, and this figure, which is the 350 hours. So the time for the 31st unit will be equal to the 355 hours minus the 350 hours, and that will give you 5 hours. Now this is a very simple illustration to show you that when you're using the algebraic approach, you have to find 2 blocks of time and subtract them. So let us apply the principle here. So if we want to find time for the 31st unit, we have to find how much time it takes to make 31 units and how much time it takes to make 30 units. So I was just using some fictitious times here. So let's find now the actual correct data. So let me change my color scheme so that you do not think that I'm using the same data, because I am not. All right. So we need to work out the time for the first 30 units. So notice now all that we have available to use is this formula. But this y is per unit. This y is per unit. So if I'm going to apply this formula to find out how many units, how much time to make 30 units, then once I find the y value using this data, I have to multiply my answer by 30. Let me show you what I mean. If I want to find the time for the 30 units, I have to find the time for 1 unit. So the cumulative average, the cumulative total time, which is what we want, is equal to what y is multiplied by 30. Likewise, if we want to find the time for the 31 units, we have to find the cumulative total time, which means that we're going to have to find a value for y and multiply it this time by 31. So y, the value for y, the unknown, always gives you your data for 1 unit, the average time for 1 unit. So let's do the calculations now. So y is equal to 120 units multiplied by 30 units raised to the power of minus b. Now this system is not cooperating, so it's minus 0.3219, close bracket. So this minus 0.3219, really it's supposed to be raised to the power, but I'm not getting an opportunity to do so. It is not cooperating. But anyway, let's work the figures. Now, my calculator is nowhere in sight and my phone died, so let me give you the figures. So it works out to be 40.14 hours. So what this is telling me is that in making the 30 units, the time on each unit is 40.14 hours. So if I want to find the cumulative total time, I'm going to have to multiply the 40.14. I'm going to have to multiply the 40.14 by 30. So let's see how many hours we get from that. 40.14 times 30. So we get 1,000 204.2 hours. Now let's do the same thing now for the 31 units. The only difference with the calculation is that rather than making x 30, we make x to be 31. So I'm just going to change this to 31 because a is still the same and the minus b is still the same. Now when I do that, my value for y comes to 39.73 hours. Let me put that in. 39.73 hours. So this is the time it takes to make one of these 31 units. So if I want to find out the total time for all 31 units, then I have to multiply that 39.73 by 31. So let us see again how much that comes to. So I'm going to copy the formula down and change this to 31 and change this to 39.73. So it means, therefore, that the cumulative time to make 30 units is 1204.2 hours. The cumulative time to make 31 units is 1231.63 hours. So it means that the time for the 31st unit would be the difference between those two figures, and it's 1231.63 minus 1204.2. And so that comes to 1231.63 minus 1204.2. That comes to 27.53 hours. So notice the simplicity of the calculation, but it's knowing how to apply it. It's knowing how to apply it in the calculation. So this is my correct data. I'm going to block it so that you know that this is the correct data. So this was just an illustration up here. So in answer to part A, it says calculate the time required to make the 31st unit. So because we're interested in the 31st unit, we have to get the whole time block for 31 units. Then we go back 1 to 30 units and find the whole time block and then subtract 2. So if we're looking at, say, the 57th unit, we would have to find the total time block for 57 units and the total time block for 56 units and subtract. Now let's look at the last one, part B, which is basically following the same approach. For part B, it says calculate the total budgeted cost for July. So because we're dealing with budgeted costs, we have to get a labor rate, and the labor rate given was $10 per hour. So you know that labor cost is always equal to the labor time in hours multiplied by the labor rate, and the labor rate in this question is $10 per hour. So how are we going to find the labor time? Again, we have to fall back on the algebraic approach. Now, the focus is the production for July. They are making 35 units in July. Sorry, 5 units in July. So cumulatively, in July, they would have made 35 units. So it seems then that what we're going to have to do for B is to look at the time for the first 30 units, which we already have, and that time was 1204.2 38.2. But we now need to find the time for the 35 units because we are interested in this block, and this block is the block with the 5 units. So we now need to find a new formula, and from that a new cumulative total time for those 35 units so that we can subtract to get the time for the 5 units in July. So we have to come back to our formula. Let me just copy this. And notice the data is still the same in some regards. A is still 120. B is still minus 0.3219. But I'm changing this to 35. So it means then that when I check my calculation, it is 38.203 because I don't have my calculator. I have to be borrowing the information from my text, 38.20. So if I want to find the time, the cumulative time for those 35 units, then it is 38.2 times 35. So notice the application of it. Two similar situations, but reasonably different. 38. One, we're looking at an additional unit in part A, 30 units and 31 units and the difference. But here we're looking at a wider margin, a 5-unit difference. So we're going to use 30 and 35. So when we work out that information, it comes out to 1337.11. So it means, therefore, that the time for the 5 units in July will be 1337.11 hours, 0.11 hour, minus 1204.20 hours, and that will give you a difference of, and the answer for the question, 132.9 hours. But what did the question ask for? It asked for the labor cost. So the labor cost would therefore be the 132.91 hours multiplied by $10 per hour. And that gives you a grand total cost of 1,329.10. And that's our answer to B. So personally, I prefer this approach because it's quicker. It's much quicker. But remember, I said to you that the approach that you will use depends on how the data is presented. And so in this particular question, notice that there is no reference to low numbers like 1s, 2s, 4s, 8s, and so on. These are huge numbers, all right? And in this case, because there's no doubling data, doubling output, we have to use the algebraic approach. All right, so this marks the end of the video, and this marks the end of the lesson, and you have a good day, and I will see you in class. Take care.